There are two pointers, one fast, one slow. The fast pointer is going to scan through the array faster. The slow pointer only moves when some sort of condition is met. This technique is called the fast and slow pointer technique, and we can use this technique to solve many coding problems. In this video, I'm going to talk about how to use this technique to solve a very specific LeetCode problem. So let's get to it. So the question that we're going to solve is question number 26. It's called remove duplicates from sorted array. So it says, given an array nums sorted in non-decreasing order, this part is important, it's sorted array, we remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same. So at the end, after removing the duplicates, we return the number of unique elements k. If there are 5 unique elements, we have to report the k is equal to 5. For example, we're given nums array 1, 2, 1, 1, 2, and at the end, the output is 2 because there are 2 unique elements, 1 and 2. Example 2 is this array is given, and then there are 0, 1, 2, 3, 4. There are 5 unique elements. That's why the output is 5. And then the unique elements are here. Okay, so that's the question. So how can we use the 2 pointers or fast and the slow pointers technique to solve this question? Let's take a look at the solution first and see how the code is going to tackle this problem using the slow and fast. Let's start from the definition of this function, remove duplicates. We're given the nums array, and then the first thing that we're going to do is to look at if this nums array is actually empty or not. If it's empty, we're going to just return 0 because there's nothing to look at. And then we're going to initialize our slower pointers. Our slow pointer right is equal to 1. It's going to start from 1 because the 0th element is unique. So we start from 1. And then we will loop through the entire array using a faster pointer. It's called read. We're going to use this fast pointer to scan through the entire array from the first position on, because the 0th position is unique, as we said earlier, until the end of this array. And in each step, as we loop through this array, we're going to compare if the faster positions, this pointer's value is equal to or not equal to the previous element. We're always comparing with the previous element. If this is not the case, if it's not equal, we have a unique element. If we have a unique element, we're going to write this unique element's value into this slow pointer's position. So we're going to only read this into this slow pointer's position if there's a unique element here. And then we're going to advance our right position, this slow pointer, by 1. This slow pointer only increments by 1 when we find a unique element using this condition. At the end, we're going to return the entire slow result at the end. This is the entire logic of our slow and then fast pointers logic. Now let's visualize the slow and fast pointer technique using the remove duplicate question. So we have an array that is sorted 1, 2, 3, 4. There are 4 unique elements. And we start from writing the slow pointer underneath 1, because that is the first unique element. The 0th element is always unique. That's why we start from the first one. So that is pointing to the first element. And then we will use a faster pointer, r, that also points to the first element. And then we're going to compare 1 to 1. Because it's the same, r is going to move to the next position. And then as it moves to the next position, it's going to compare 2 to 1. Because these two are not the same, and then w is going to move 1 position, and then r is also going to 1 position, and this 1 is going to change to 2. Let's see. Next, as you can see, as it moved, it's going to change this first position to 2. And then now it's going to do it again. So r is going to move 1 position to the right. Because 2 is the same as 2, it's not going to change anything. So as I click next, it's not going to change anything. And then r is going to move again. So as I move it to the next one, because we found 3, which is different from 2, it's going to change this w's position, which is 2 into 3. And then this w is going to move 1 point to the right. As you can see, this changed and then r moved again. Next time, r is going to move to the next position, and these two values are the same. Nothing changes. So as I move, nothing changed. and then R is going to move one position to the right. It's going to change this third position, and then R is at the end of the array. So this is how we're going to solve this problem, and then the resulting array is going to be 1, 2, 3, 4, and then we found our 4 unique values. Now let's paste our solution here, and then try to run this. As you can see, it is run successfully and accepted, and then it has a very good, one of the good solutions that we've created. That's the end of today's BitSize DSA video. Hopefully you learned a lot. In our next video, we're going to continue to solve more problems with the 2 pointers technique. If you like this content, please subscribe and check out other similar videos.